Good morning everyone. Myself Dr. Pranav Kumar. Today I am going to speak on the topic cryptography and cyber security. Cryptographic technique is mainly divided into symmetric and asymmetric key cryptography. So what is the difference between symmetric and asymmetric key cryptography? So symmetric key cryptography is something in which we can say same key is used as at the source and the destination. Means there will be a single key that is used for encryption and also for the decryption process, right? Whereas in asymmetric key cryptography, different key is used for encryption and decryption. So let's see the main difference between the symmetric and asymmetric key cryptography. So in symmetric key cryptography, it requires only a single key for both encryption and decryption process, right? Whereas in asymmetric key cryptography, it requires the two different key for encryption and decryption process. Second point is that, second difference is that the encryption process of symmetric key is very fast. So why it is fast? Because single key is used for the same process, encryption and decryption. So that's why this whole symmetric encryption process is faster as compared to the asymmetric, right? So the third comparison is that one, it is used for the large amount of data, right? So symmetric encryption is applicable for the large amount of data required to transfer from source to destination, right? So it will be easy for anyone to apply this encryption technique easily for the large amount of data, because we don't have to encrypt each and every packets of that data with two different keys, right? Here we are using the single key, that's why, right? Whereas in spite of symmetric, in asymmetric, it is only applicable for or preferable only for the small amount of data, right? So fourth difference is that it only symmetric key cryptography only provide the confidentiality. Means we can ensure that if we encrypt through this symmetric key algorithm, the confidentiality will be there onto the data, right? Whereas in if we use asymmetric key algorithm, definitely we can say that confidentiality will be there. Along with that one, integrity and that availability and authenticity will also be there, right? So this is the fourth difference. We can say differentiation between the symmetric and asymmetric key cryptography. The fifth one is that we can say that when we encrypt the symmetric key encryption technique, when we use that technique, the cipher text size will be approx limited to 128 bit to 256 bit, right? Whereas if we use asymmetric key encryption technique, that the size of the cipher text, or we can say length of the cipher text or the key, will be 2048, or it may be higher than that, right? So as you can see, there is a lots of difference between the symmetric and asymmetric length of keys, right? So this is the sixth difference, we can say. Seventh difference is that in symmetric key encryption, we can say the efficiency, or we can say it is less efficient as compared to the asymmetric one, because in asymmetric there is we cannot use for the large amount of data, whereas in symmetric we can use for the large amount of data, right? So these are the mainly difference between symmetric and asymmetric key encryption. So there are some of the examples for symmetric and asymmetric key. So onto this session, or we can say onto this first part of video, we will be discussing about the symmetric key examples, right? So first example, or there are let me mention some of the examples of symmetric key cryptography algorithms. These are we can say, first one is Vernam cipher, that is also called as one-time password, one-time pad. Second example, we can say Hill cipher. Hill cipher is commonly used for this symmetric encryption technique. Third one is Playfair cipher. right? And fourth one is data encryption standard technique, right? So let's see one by one what are those encryption technique. So let's start with the Vernam cipher. So as you can see onto the board, for encryption technique we need two things, two basic things we can say. First one is called as the plain text, or we can say the text message that we have to convert into the encryption form, and another one is that we need a one-time password, or we can say key, right? Encryption key that is required for the encryption process, right? So in Vernam cipher, that OTP is required, one-time password is required for encryption method, right? So suppose for example here our plain text will be HELLO. Hello is our plain text, right? So everyone knows the alphabetic characters, right? So in English we have 26 total characters, right? So we have to number those characters one by one. For example, A, B, C, D, E, F and so on, starting from the 0, 1, 2, 3, 4, 5, 6 and so on. We have to number it like that, right? So on to the second step, we have to convert this message into, or we can say this character into the number format based on this one, right? So H will be, according to that conversion, H will be it will be A, B, C, D, E, F, G, H. It will be 7. H will be 7. E will be 4. L will be 11. Again L will be 11, and onto the same conversion, when you will check, O will be 14, right? So this is the number conversion of the text message, or we can say plain text message, right? So this is the first step, this is second step. On to the third step, we have to select one time password. It can be any password, it can be anything, right? So here we are selecting some random password, or we can say random key, right? Right? So here we have selected some random key, that is BAXYC, right? As you can see onto the board. So we have to convert, we have to follow the same process, that is the conversion of this character into the number format based on this one, right? So B will be 1, A will be 0, right? X will be 23, Y will be 24, C will be 2, right? So this is the conversion of this one, right? Of our OTP. Now on to the next step, that is the fifth step. On to the fifth step, we have to add these two. Right? We have to add these two values, right? So on to the addition, क्या होगा 14 plus 2, it will be 16. This 11 plus 24, it will be 35. This 11 plus 23, it will be 34. This 4 plus 0, this will be 4, and this 7 plus 1, it will be 8. Right? This is the output of our addition process, fifth step, right? So on to the sixth step, we have to check whether onto these values, which value is greater than, or we can say value is greater than 25, right? Not equal to 25. It should be greater than 25, right? So we have to check whether which value is greater than 25. So 8 is not greater than 25, 4 is not greater, this one. 34 is greater than 25, 35 is greater than 25, right? As you can see, 16 is less than 25, right? So if we found any value which is greater than 25, we have to subtract that value with 26, right? Clear? So we will subtract these values with 26, right? Rest will remain the same, that is 16. This will be 9. This will be 8. This will be 4 and 8, right? So this will be our cipher text, right? So we have onto the 7th step, we have to convert this value into the character format. So onto the 8th, we can say I will be at the 8th position. So this will be I. 4, what is 4? Serial number 4 is E, right? Onto the 8th position, again I is there. 9th position, J is there, and onto the 16th position it will be Q, right? So our cipher text will be I, E, I, J, Q, right? Clear? Easy to understand, right? So let's discuss the decryption process of this one, right? So